Welcome back. This is Mrs. Karn. Today we're going to talk about special polynomials. So I would recommend that you pause the video, write down the formulas, and then come back and join me. These first two formulas about a perfect square trinomial and a difference of cubes, those are formulas that we've used in the past. I'm just going to do a simple example for this difference of cubes. A difference of cubes means you have a squared term minus a squared term. And this formula gives us a shortcut that we can use to find the factored form. That's our goal today, is factoring these special polynomials. And remember, factoring means you take something and you break it into parts that multiply together. So 8 could be factored into 2 times 4, or 8 could be factored into 1 times 8. That's what factoring means, to separate it into two factors or two terms that are being multiplied together. So if we had an example problem like x squared minus 9, if we were to try to factor that, we would say, well, we know both of our factors are going to have an x. We know we're going to have different signs since it's a minus. And we look at factors for negative 9. That could be 1 times 9 or 3 times 3. But we know we want them to add up to be a 0, right? Because we really have x squared plus 0x minus 9. They have to add to 0, so the pair that would be add to 0 would be negative 3 and positive 3. So our factors would be x plus 3 times x minus 3. Sometimes in the past, just to help your memory, we've done that with an x, where we put a times c in the top and we put b in the bottom, and we were looking for those numbers that multiply to negative 9 and add to 0. So if we were doing that same problem, but instead of doing the step-by-step factoring process, we were to simply use the formula. Well, x squared is x squared, and 9 is 3 squared. So if we compare to our formula, our a value is x, and our b value is 3. And then we just fill in the pieces to the formula. We have a minus here and a plus here by the formula. Our a value is x, and our b value is 3. So that would be another way to factor it using the formula. What we're going to focus on today is factoring sums of cubes and difference of cubes. So this is what we're focusing on today. And to do this, we are simply going to use the formulas. We're not going to spend any time factoring by hand. We're simply going to plug in our pieces to the formula. So we simply have to identify what's our A and what's our B. A quick review before we do that. The numbers that are perfect cubes, we could do 1 cubed makes 1, 2 cubed makes 8, 3 cubed 27, 4 cubed 64, 5 cubed 125. And you could just continue that list to help jog your memory for numbers that are cubes. The next 6 cubed would be 216, 7 cubed 343, 8 cubed 512, 9 cubed 729, 10 cubed 1,000, etc. So when we look at these problems, again, we're going to be using those formulas. This is a sum of cubes in our first example problem, so it's going to be a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So if we notice, we could write this as x cubed plus 3 cubed. 3 cubed is 27. That means our a value is x, our b value is 3, and then we're simply going to plug into the pieces to find our factors. So we've got a plus b, and then we've got a squared minus ab plus b squared. So a is x, and b is 3, so b goes here, and b squared goes here. So here we're putting b squared, 3 squared, which is 9. In the middle, we're doing a times b, so that would be 3x. And that's all there is to it. We just fill in the pieces of the puzzle. Next problem is also a sum of cubes. Our first term is 2x quantity cubed. Our second term is 5 cubed. So that means our a value is 2x and our b value is 5. So following our formula, parentheses, a 2x plus b 5 times a squared plus a times b plus b squared, right? So that's just filling in the pieces, and now we're going to go back and write it a little bit nicer. Final form, 2x plus 5. Our 2x quantity squared makes 4x squared. 2x times 5 makes 10x, and then 5 squared is 25. So that is the factored form of our sum of two cubes. This is our answer. Next problem is a difference of cubes. So our formula in this case is going to be that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So this first term is not a perfect cubed, right? 3a to the third. 3 is not anything being cubed. So the other thing that we can check for, which we really ought to be always checking for anyway, is a greatest common factor. If we look at both of these, they are both divisible by 3. So we're going to use a GCF of 3. If we pull that 3 out front, we're left with, let's get rid of this here. If we pull that 3 out front, we have 3 times a cubed minus 27x cubed. And that is the same thing as 3 times the quantity a cubed minus 3x quantity cubed. So we have our a value is just a, that's kind of nice, and our b value is the 3x. So our final answer, we still have the 3 in front, and now we're going to have our formula. We've got a minus b times a squared plus ab plus b squared. So a is a, b is 3x, a squared would be a squared, a times b would be 3ax, and then b squared would be 3 times 3, 9, x times x, x squared. We don't necessarily need those brackets. We could just write it 3 times a minus 3x times a squared plus 3ax plus 9x squared. That's our factored form of that difference of two cubes. Next example, again, we have a GCF, but this time it's a little bit bigger. These terms are both divisible by 3 and by x. We talk about that GCF. We want to take out the greatest thing possible. We want to take out the largest term we can. And then that leaves us with x to the third minus 1. So if we think about our a and our b value, we have 3x times x cubed minus 1 cubed, because 1 cubed is just 1. So we have an a value of x, and we have a b value of 1. So filling that into our formula, we've still got that GCF of 3x in front. We have x minus 1, and then we have x squared minus 1x. That's a times b is just 1x, and then plus 1 squared is 1. So that's the factored form of that difference of two cubes. Okay. Another example. Oops. This one is a sum of two cubes. So again, we're going to make sure we use the correct formula. In this case, that correct formula, a squared plus b squared, is a plus b times a squared minus ab plus b squared. And then we're going to look for a greatest common factor, because we're going to pull that out first. These both have an x, and that would be the only common factor. So we have x times 8x cubed plus 27. And we know that 8 is 2 cubed. So our a value is going to be 2x. And then our b value is going to be 3. So we've got the x in front. We've got a plus b. So we have 2x plus 3. And then we've got a squared. So if a is equal to 2x, then a squared is equal to 4x squared. And our b value is 3. So a times b is going to be 2x times 3, or 6x. And then Since b is 3, b squared will be 9. So, whoops, plus 9. And since I have something wrong, do you notice that in the middle here, my formula has a minus? Formula is a minus here, so I needed a minus right here. So that is the factored form of our sum of cubes. Okay, one more example to look at, which is a difference of cubes. Again, we're going to check to see if there's a greatest common factor that we can clear out. And they both have at least one y, right? So we're going to pull that y out front. And that leaves us 64x cubed minus 125y cubed. And now we can find our a and b values. Our a is going to be 4x, and our b will be 5y. So we have y times 4x cubed minus our b value, which is 5y cubed, or the b value being cubed. Now we're going to just follow our formula. So we start with the y, then we have a minus b, so 4x minus 5y. Then we have a squared, so 16x squared plus a times b, 4 times 5 is 20xy, plus b squared, 5 times 5 is 25y squared. And that's the factored form of that difference of two cubes. Some additional videos of this are posted on Canvas, a couple from Khan Academy and a couple from the textbook. So if you think you'd like to see more examples, take a look at those and then work on the IXL practice.